Hello and welcome to this first video of a tutorial series in which I'm going to demonstrate the new TTK cinema filters. So in a nutshell, cinema databases are very simple file-based databases that can store any kind of data product. For example, products can be color images of a simulation, contour trees, persistence diagrams, meshes, and so on. The implementation in TTK uses VTK file formats to store these products. So VTI for images, VTU for persistence diagrams, and so on. The nice thing here is that the abstract VTK formats can represent almost any kind of data, so you can always find an appropriate container. In addition to the products themselves, a cinema database also contains a table that associates products with properties. For instance, we can store for each product its corresponding time step or other parameters. If you want to learn more about the inner workings of cinema, you can check out the website cinemascience.org, where you can also find the current cinema specification. Okay, so let's now have a look of how we can utilize cinema with TTK. And believe me, it will make your life much easier. In this demonstration, I will generate a new cinema database containing only images of an object. By the way, this was the original idea behind cinema. That is, instead of storing entire simulation states, let's just store images of the simulation and afterwards browse the image database in real time. So for this simple example, I load the dragon dataset and apply the elevation filter just so that we have some scalar values on the mesh. So now imagine this pipeline would be computationally expensive. Then you want to store the progress you made so far, so you don't have to rerun the pipeline every time you want to continue working with your results. So let's add a cinema writer filter at the end of the pipeline that will store the results of the computation in a new cinema database. For this, I also need to specify the location of the database, and let's just use some folder in my home directory. When I hit apply, it will store the input data, in this case the entire mesh, in the database and append its entry in the data.csv file. This filter will also use compression to reduce the database size as much as possible. Okay, so let's delete our pipeline and load the database we just created. For this, I create a cinema reader filter where I have to specify the path to the database again, which was just in home Jonas test mesh.cdb. After I hit apply, it will load only the data.csv file of that database to inform me what data products are available. In this example, the database only contains the dragon mesh. Therefore, we can directly load the data by running the cinema product reader filter. So here's our previous result. Obviously, this methodology starts to really shine when there are a lot of products and you want to query specific ones. This will also be an example in a later video. And now imagine storing the entire mesh would use up too much disk space. In such a case, we don't want to store the mesh directly. We could, for example, only store images of the object. So for this, we need to specify the location of the cameras. Therefore, I create a sphere whose vertices will be used to center the cameras. Now I have to adjust the radius of the sphere so that it contains the entire data set. And I will change the representation to wireframe so that we can have a look inside. Yep, and those are way too many camera locations, so let's just reduce the resolution of the sphere so we will generate only 6 images. So now to actually generate the images, I will run the cinema imaging filter, where one input is the dataset that we want to depict, and the other one is the sampling grid, which contains the camera locations. Now I also have to set some parameters like the resulting resolution of the individual images and the camera near far plane, camera focus, the camera height, and that of course depends on the scene. For the dragon, I will just use a near far plane setting from 1 to 300 and an image height of 220 in world coordinates. So that's roughly the height of the dragon. Okay, now I will create a new render window so we can have a look at the generated images. And after I hit apply, it will generate the images, where each image is a block of a BTK multi-block dataset. And here we can see one of these images. So let's store these images instead of the mesh in a new cinema database. So I run again the cinema writer filter, where I specify now a new path to a database, again in my home directory, but this time let's call it images.cdb. Okay, so let's delete again this pipeline and just load again the new database. So I run again the cinema reader, and I want to specify the path here, and I want to see it here in the spreadsheet view. And now we can see that in this database are actually 6 products. Those are the 6 images we just created. And let's just load all of them with the cinema product reader. And let's change this again to surface so we can have a look at the images. And to view all of these images at once, let's run the cinema layout filter that will just arrange the images on a grid. Yep, here we go. And now comes the really cool part. The images do not only contain the depth values of the depicted mesh, but also the raw scalar values that were depicted at the pixels. So we can apply post-hoc color mapping and even run some threshold filters on these scalar fields. So let's have a look at the elevation scalar field that is stored on those images. And yellow encodes here the background, which is basically not a number. So to get rid of this, we can run a threshold filter where we want to threshold the elevation and just take all the values that are a number. So we get rid of the background. Okay. And then we can do even some further processing by, for example, filtering again the elevation. For example, let's take everything that's above 0.5. And since we have access to the original scalar field, the raw scalar values, we can apply post-hoc color mapping and just change this here and do processing as we are used to in ParaView. Okay, so that is it for this video, but this was just a very rough overview of all the new functionality that's in TTK. In the next videos, I will provide some more complex examples and explain the individual filters in detail. So thanks for watching.